Good morning, Professor. My name is Chandana Pati. I'm here to explain my project Bayesian LSTM with Monte Carlo dropout for uncertainty aware forecasting. My teammates are Dimple Alekia Basimi and Mahidar Patakuri. So here I'm presenting my report. This work is for the computational methods for statistic course, and we are three members. So when it comes to abstract, traditional LSTM models give predictions without telling us how confident they are. But in real life, like finance or health, we need to know how sure a model is. So we used a method called Monte Carlo dropout with Bayesian LSTM to get both predictions and confidence levels. So this is the references we used for our project. So when it comes to motivation, in fields like weather, finance, or disease forecasting, a wrong prediction can be dangerous. So we just a number is not enough. We also need a confidence interval. So standard LSTM method doesn't show uncertainty. So we have used Bayesian methods, but full Bayesian methods will be little slow. So we have used Bayesian with uncertainty model, which has dropout method during both training and testing estimation and to estimate the uncertainty in the faster way. So when it comes to like how we implemented the algorithm, so normally LSTM means like least short term model. It gives only one output. So with our method we run the model many times, like by owning the dropout. For example, like we have a number of uh, like to execute the number of values. So first we will on one value and off the remaining value, like it comes under the off situation, then it considers only one value to give the output continuously. So this gives us different predictions each time. Then we calculate the average prediction and spread the variance to show the confidence. So the project is implemented in a GitLab, and also we have submitted the report. So my teammate Mahidar will explain how we implemented it in the GitLab, and also how the project has been implemented. Thank you.
Good afternoon, Professor. Today in this project, I'm just implementing. I'm going to implement and the project, and I did the implementation and optimization and dataset. Uh, First, coming to the mathematical formula. Sorry. Yeah, this is the mathematical formula we have used. We estimate the prediction as an average multiple model runs. The variance between these runs shows how uncertain the model is. This is based on a method from Gal and Grahmani in paper 2016. I've taken these two. This is the main goal of this output of our project is it's Bayesian inference, and we have taken Monte Carlo dropout approximation. This is the formula for that, the basic equation for that, and after going to this, we have also calculated predictive mean and variance, and we have also calculated these are the main LSTM equations for the given context. Uh, these are the basic equations we have used. These are the brief rebriefing of the given equations, and our goal is to just find these tune this mathematical model to the Python code. The other thing we have done is we changed this Bernoulli equation. We have used all these, and I will just show the code of our project. Okay. Uh, we have simulated our forecasting with the help of this sine function. Ours is a time forecasting project, so that we have generated a synthetic data which is a sine function, and we have splitted the data, and we also trained this model with the help. This is the model we have used here, and I've used 20 epoch here to predict the MC dropout, and we got these results. This is just a simulated sine wave, and after doing this, we jumped into the real world temperature forecast. We have taken this example here. We have taken real world. It is Melbourne temperature. Then we tested on daily real time temperature from Melbourne from 1981 to 1990. Our model tracked the two values and showed meaningful confident bands. This proves our model works in realistic situation also. Here I will just show you how we have like implemented this, and how we have loaded the data from the GitHub repository where we have taken this data from, and we have did we did all the data pre-processing here, and we have splitted the train and testing here. And after doing that, I have trained this model on our project, which is Bayesian LSTM. Here you can see I've also defined a vectorized MC dropout. After doing that, I've also predicted here, and we got these kind of results here. Here you can see the red line, which indicates us the average mean prediction of the temperature, which exactly very much good experience, like very much good results I've seen here. After doing this, we have also compared the analysis of all these more like these. We have also compared these LSTM models with the standard and the profit, which is a Facebook thing. It's the additive model from the Facebook. Here we have compared between all these three models. Here you can see we have did our package. We have did our project with the help of this, and we have also like imported that package, which is base LSTM, and we also did these two files from there. This is the implementation of that, and we have loaded Melbourne temperature, and all this we have already shown in the last file. And after doing all this, we got the results as this. You can see for the standard LSTM, we got RMSE as 2.2119, and the mean average error is 1.73. And for the Bayesian LSTM, we got the RMSE is 2.26 and MA is 1.7731. And for the profit model, which is the Facebook thing, we got RMSE as 3.2 and MAE as 2.5. From here on, my teammate Alekia will continue.
Hi, Professor. I'm Dimple Alekia Basmi. So, as my friend already told the comparative analysis, here are the three comparative analysis we have compared. One is standard LSTM. So it is fast and accurate, but no uncertainty. And the next one is profit. It is like very good and fast for seasonal data. And coming to the last model, it is like Bayesian LSTM. It is best when it is important to know how confident the model is. And these are the comparison and insights. And coming to the discussion and the conclusion, that is the summary of what we have done. We have built and tested a Bayesian LSTM using Monte Carlo dropout. It gives good forecast and also tells us how confident the model is. And we've also optimized the code and made it reusable for the others. And here are a few observations that we have done. And these are the strengths of the Bayesian LSTM. Like, it is very easy to implement using dropout based approximation, and it is high flexible for it monitors the health, climate modeling, and it is applicable to stock predictions. These are the strengths of Bayesian LSTM. And coming to the limitations, we have some limitations in this model, like it may underfit complex data if it is not tuned well, and it takes more time during the prediction, and it requires careful calibration of dropout rate and number of samples also. And in future, like these are the future directions. In future, we can try Bayesian methods like base by backprop, and we can do multi-step forecasting, and we can use more real-world features like holidays and events, and we can test on more violate or multimodal data set. And these are the like the final takeaway from the project is like our project shows this that uncertainty is very important in forecasting. Bayesian LSTM gives a balance between neural networks, and it predicts, it gives good predictions, and it is trustworthy. And these are the research papers we have referred through, and this is the data set we have taken for this project, and these are the tools and libraries we have used for the project, and this is the usage notebook. So thank you for listening to our report. Thank you.
Stop.